Hi, welcome to this video on exact values of sine, cos and tan. Okay. In this video we're going to be looking at special triangles and special angles where sine, cos and tan turn out to be not sort of horrible, irrational, never-ending numbers like I've got there for cos 36, but some special results, and they quite often involve surds. If you haven't watched the video I've put out on rationalising the denominator yet, you need to do that one first because it pops up in this topic as well. So for most angles, like I've got there, cos 36, you'll get for sine and cos 0 point something, it'll be horrible, it'll go on forever, it'll be irrational, and for tan it's even worse because they're not even limited to between -1 and 1. Okay. But for certain triangles, and the first one I'm going to show you is a 45-degree triangle, you get some special results. The trick with these is knowing what the lengths of the sides are, and these are standard proofs and you need to learn these triangles. You're going to need them in your exam. So for a 45-degree triangle, and 45 degrees means it's kind of based on a square that's been split diagonally. So the length and the height are the same, and we say that they are 1 each. So 1 and 1. The units don't matter because we're just looking for values here. You can apply it to any triangle of any units, meters, centimeters, millimeters, doesn't matter. So using Pythagoras then, to get the hypotenuse of this triangle, I would need to do the square root of 1 squared plus 1 squared. So that's the square root of 1 plus 1. Which is the square root of 2. So the diagonal of this triangle is root 2. Now, to use sine, cos and tan, that's trigonometry, I need to label these sides O, A and H. So here's my hypotenuse, here's my opposite, and here's my adjacent. So if I go in the order that you get them on a calculator, so sine 45, sine is O over H. So O is 1 and H is root 2. So 1 over root 2. Cos 45 would be A over H. And again, that's going to be 1 over root 2. So they're both the same, and that's because O and A are both 1. Then tan 45, which is O over A, is the nicest one of all because it's 1 over 1, so that is just 1. So for a 45-degree triangle, that's okay. Sine and cos both come out the same, and tan just comes out as 1 anyway. So there's your first set of exact values to learn. And what you really need to know is the triangle they come from. If you've got the triangle, you can work out sine, cos and tan on the day when you need to. If we look at the next one then, the next special angle we'll look at is a 30-degree triangle. So this time we have 1, and then we put 2 on the hypotenuse. Okay, just a proof you need to learn, don't worry so much about why. And the surd this time will come on our adjacent side. Okay, so using Pythagoras, and it's taking away Pythagoras this time, it'll be the square root of 2 squared take away 1 squared, which is the square root of 4 take away 1, which is the square root of 3. So root 3 goes there. Okay, now root 3 is bigger than 1, not by much, but it is bigger than 1. So if I've got my 30-degree angle at the bottom, then my opposite has to be 1 and my adjacent is root 3. Don't get those muddled up, okay? The opposite side will be shorter for a small angle like 30 degrees. And then we just work through it in the same way. So if I do sine 30, which is my angle, I get O over H. So that comes out really nicely because there's O, there's H, A's down the bottom, we just get 1 over 2, it's exactly a half. You get that a lot in A level. They deliberately put in 30 degrees because they know it'll simplify to a half if you do the sine. Then we do cos 30, which is a over h. So not as nice this time. That's root 3 over 2. And there's not a lot you can do with that on its own. You can, when you put it into a problem, sometimes tidy that up a little bit. And then lastly, we'll have tan 30. And tan is O over A, so that's 1 over root 3. Okay, so again, not great that one. If you put it into a problem, you can tidy it up a little bit. Rationalising the denominator often helps. So again, if you haven't watched that video yet, you need to before we get into some questions. So we've done 45, we've done 30. The last one then is based off the 30, but this time looking at the 60, which actually on the same triangle, if I can get these both on the screen at the same time, it's the same triangle, but the 60-degree angle would be at the top because the 30-degree angle was in the bottom left. Okay. The measurements of it are actually the same. So we've got a hypotenuse of 2. We've got 1 there and root 3 over there. The difference is now, though, because I've moved the angle, h is still 2, but this time a is 1 and o opposite is root 3. Okay. This now the longer of the two sides is the opposite because of the big angle, 60 degrees. So that gives me then sine 60 o over h. Well, o is root 3 and h is 2. That was cos 30 before, now it's sine of 60. We've got cos 60, which is a over h, which is our 1 over 2. So we had that previously for sine 30, and now we've got it for cos 60 because o and a have switched around. And then we've got tan 60, which is o over a, so 1 over, oh sorry, root 3 over 1. Got my o's and a's upside down there. So root 3 over 1, which is just root 3. You don't need to worry about putting the 1 in. Okay. So you need to learn your triangles. You need to get their measurements, you need to get your angles in the right place so that the sides are in the right place. There's no way around that really. You just have to sit down and practice them and have a little look over them before any exam you go into. But when you get into an exam, draw your triangle and then you'll know your sines, your coses and your tans for that particular angle. Okay? If we have a look at some examples then with actual numbers. And what I've got up in the top left there is all of the things we've just done condensed down to, ignore the 0 column by the way. So I've got my 30, my 45, my 60, and I've got my sine, cos and tan for each of those. And it's not that different to what you did in year 9, except that we can put in our exact values into our trigonometry calculation. So if I label my sides, this is h, this is o. I'm not interested in A in this question, so it's a sine question. So if I start by saying that sine 30 equals O over H, so X over 12, I need to times by 12 to leave X on its own. So 12 times sine 30, now this is where you need to use your exact value. So looking at your table, the sine of 30 is a half. So 12 times a half is x, and a half of 12 is 6. Okay, that one comes out nicely because it doesn't have any surds in it. Okay, deliberately started with that one. So all we're doing, look, is making a bit of a substitution. Sine 30 is a half because up in my table, sine 30 came out as a half. If we look at the next one. Still 30 degrees. This time in my question, I've got H and A, so this is a cos question this time. And cos 30 is root 3 over 2. So we've got cos 30 equals A over H, so that's X over 8. Bit like last time then, we need to multiply by 8 on the left. So we're going to get 8 times cos 30. Cos 30 is root 3 over 2. So 8 times root 3 over 2, which is just 8 root 3 over 2. And because 8 can be divided by 2, I can tidy that up a little bit. That would be 4 root 3. I can't do anything with the root 3, but I can do 8 divided by 2 is 4. So 4 root 3. Here's another one. This time I'm using a 60-degree angle. Okay, so make sure you're using that last column on the table. Here's my opposite. 5 is my adjacent. This is a tan question. So tan 60, I can see there is root 3. I'm going to need that in a minute. So tan 60 equals, it's O over A, so that's x on the top, 5 on the bottom. That's going to become 5 times tan 60. 5 times tan 60. Tan 60 from the table is just root 3. So 5 times root 3 is just 5 root 3. So x is 5 root 3. Okay, and you can't do anything with that, it just is 5 root 3. So if you want to have a pause the video and have a go at this one first, see if you get the same as me. This time we're working with a hypotenuse, which is our x, our missing value, and an adjacent. So this is a cos question. A little bit different this time though. Cos 60, now it's a over h. So this time it's 4 over x. Now when x is on the bottom, you've got to do a bit of swapping around and rearranging. And what you end up with is 4 over cos 60. Now going to my table, cos 60 is a half. So that's 4 over a half, which is a horrible way of writing it. I can write it as 4 divided by a half, maybe looks a little bit nicer. To divide by a fraction, you need to find its reciprocal and times. So that becomes 4 times 2 over 1. 4 times 2 is 8, and 8 over 1 would be just 8, so 8 centimetres. So that's quite a nice one because we had the half again. Okay, we've got a 60 now then, another 60. We've got our opposite and our hypotenuse. This is going to be a sine question. So sine 60, okay, that's not very nice. We'll have to do what we can with this one. Sine 60 is O over h, so that's 9 over x. Again, x is on the bottom of the fraction. We need to swap it, rearrange it, change the subject, however you want to say it. 9 over sine 60. Now sine 60 is not very nice, it's root 3 over 2. So 9 over root 3 over 2. But again, it would look a bit nicer and maybe make a bit more sense if I wrote it as a division. So 9 divided by root 3 over 2. I'm going to use the same rule I just did. I'm going to flip the fraction, find its reciprocal, and I'm going to times. So that's 9 times 2 over root 3. I'll move that down a little bit. So that's 9 times 2, which is 18, over root 3. Now, if you've watched my rationalising the denominator video, you'll know that we don't like to leave a root 3 on the bottom. And the way to get rid of it is times the top and the bottom by root 3. So that's then going to give me 18 root 3 over 3, because the root 3 times root 3 on the bottom will just give me a 3. So I've rationalised my denominator, and actually the numbers have turned out really nice because I can work out that 18 divided by 3 is 6. So the nicest simplified version of that answer would be 6 root 3 centimetres. Okay, so let me get a bit more of that on the screen there for you. Okay, so 6 root 3. Always trickier when you're finding a hypotenuse in a sine or a cos because of the division part. And then if you're dividing by a fraction, you need to know your rules to flip it and times. Okay. Then I've got one more, so I thought I'd better show you a 45. though the 45 is not as difficult as the 30s and the 60s. So we've got h, which is our unknown, and we've got a, so it's a cos question. Cos 45 equals a over h, so that's 8 over x. Now cos 45 is 1 over root 2. So after we do our swapping, so hold on a second, let's swap this round. So we get x equals 8 over cos 45, which gives us x equals 8 over 1 over root 2. I don't like it looking like that. So 8 divided by 1 over root 2. Again, flip your second fraction, change it to a times. That gives us 8 times root 2 over 1. Now 8 root 2 I can't do a lot with, 8 times root 2, so it is just 8 root 2. And it's being divided by 1, which is nothing. So that just stays as 8 root 2. And then don't worry about dividing by 1 because it'll do nothing anyway. So 8 root 2 would be your final answer there. Okay, so that's how you find your exact values of trig. You must learn your triangles. And then how you would use it. So you would do everything you would normally do for a trigonometry question, but substitute in your exact value for your sine, cos or tan, theta part.